All right, today we're going to do 8.5 factoring by grouping. Just to review what we have covered so far in factoring, when we have a trinomial, so we factor a trinomial, that is of the form ax squared plus bx plus 3. That's the three terms. We are looking for factors of c that add or subtract. That depends on the second sign, whether we add or subtract. Right here, that's the second sign, to b. So factors of this term that add or subtract depending on the sign to b. So we did that, had a test on that previously, and then yesterday we factored binomials. That is a squared minus b squared. So two terms, and they both must be squares, and we must have subtraction. So we want to find, this is the difference of squares, and again, difference means subtraction. And to do this, we take the root of a and b. Our answers. That was yesterday. All right, last one now we have is 4-term polynomials. And we're going to do this by grouping. So if I have p times q plus 1 minus 4 times q plus 1. The way that this works is these two terms right here, these must be the same. These have to be the same. So the ones are the same, I just rewrite q plus 1. Now, these two right here, the p and the negative 4, these are the two outsiders. They do not belong to a group. The q plus 1 belongs to a group, so it keeps their group together. P and negative 4, these are not in a group, so they're going to merge together, and they're going to form their own group of p minus 4. So the ones that already are in a group, they stay in a group right at once. The two outsiders will form their own group. So if we have 6x cubed plus 3x squared plus 2x plus 1. We're going to divide this in half. So here is the first part of my problem, and here is the last half. We're going to find the GCF. So what is the GCF of this first part that's underlined? We have a 3 in common with 6 and 3. We have two x's, and the 2 is the smallest one. So 3x squared is the GCF of the first half. We then divide them both by 3x squared. So 6 divided by 3 is 2. Then subtract the exponents. 3 minus 2 is 1. Then 3 divided by 3 is 1. 2 and 2 is 0. So this will be 2x plus 1. Now the second half of the problem, what is the GCF of 2x plus 1? Remember, every problem has a GCF, or every term, they all have a GCF of at least 1. And so the only thing that goes into 2x and 1 is going to be 1. So I'll write plus 1, and I still have my 2x plus 1 at the end. Now, once I do this, if you notice what happens, the two terms on the inside in the group, these are the exact same. So I'm going to rewrite 2x plus 1. I then take my two terms on the outside that do not belong to a group. And I'm going to take these two, and they form their own group of 3x squared plus 1. So I factored by a four-term polynomial. I factor by grouping. I take the first two terms, factor out the GCF, take the last two terms, factor out the GCF. At this point, this term here, these terms inside the parentheses must be the exact same in order to do this. All right, so let's say we have 10x cubed minus 25x squared plus 4x minus 10. So once again here, I have three terms in my problem. So to do three terms, I divide it in half. Here's the first half of the problem, and then here's the back half. So I want to know what is the GCF of 10x cubed and 25x squared. Well, 5 goes into 10 and 25, and 3 and 2, remember the smallest exponent is always the GCF, so it's 2. So I divide these both by 5x squared. So 10 divided by 5, that's 2. 3 minus 2 is 1. Negative 25 divided by 5 is negative 5, and the x squared cancels. The 4x minus 10, 2 is our GCF here. So I put plus 2. I divide both terms by 2. So 4 divided by 2, that gives me 2x. Negative 10 divided by 2 is negative 5. And once again, if you look, the terms inside the parentheses are the same. So I rewrite 2x minus 5. I then have my two outside terms that do not belong to a group. They're going to merge and come together and form their own group of 5x squared plus 2. So the answer to this one is 2x minus 5 times 5x squared plus 2. And again, that's with four terms with grouping. All right, so now what if we have x to the 8th minus x to the 6th minus x squared plus 1. All right, once again, we divide it in half, the first two terms and the last two terms. So the first two terms, the GCF will be x to the 6th, which leaves me with x squared minus 1. Remember, it's the smallest exponent. The last half of the problem, there's nothing in common except a 1. However, if you notice, the x squared here is positive and the 1 is negative. Up here, the x squared is negative and the 1's positive. They have to match inside the parentheses. Remember over here, the parentheses, they're all the same over here. So I need the parentheses here to be the same. So I'm going to factor out negative 1. And by doing that, the negative x squared becomes positive x squared, and the positive 1 becomes negative 1. And by doing that, now my terms inside are the same, x squared minus 1. I take my two outside terms, they come together and become x to the 6th minus 1. Now we have two binomials. Now we're combining how to factor. The instructions will be factor completely. Now I have a difference of two squares. I have a square here and a square there. 1 times 1, and half of 2 is 1. So this becomes x minus 1, x plus 1. And this one is also a difference of two squares. Half of 6 is 3. So it's x cubed minus 1 and x cubed plus 1. So here we've combined difference of squares, factoring binomials, with factoring a four-term polynomial. So again, we can combine multiple ways to factor a problem based upon what we have and the number of terms that we have in a problem. All right, so next here we have mx plus 2m plus nx plus 2n. So even though we have variables here, we're doing the same. We got 4 terms. Look at the first 2 terms and the last 2 terms. So the GCF of mx and 2m is going to be just the letter m. Take away m, I have x plus 2. The last 2 terms here, I have an n in common, so I put plus n. Take away the n, and we have x plus 2. So once again here, I'm going to take the terms that are inside the parentheses, the x plus 2, and then I take the 2 that are outside, the m and the n, and they become m plus n. So the way we factor that becomes x plus 2 times m plus n. All right? Now we have 4r squared s minus 8rs minus 3r plus 6. So again, we have 4 terms. We divide the first 2 and the last 2. So the first 2 have a 4 in common. They have an r. R to the first power is the smallest exponent, and they both have an s. So when we divide by 4rs, that gives us r minus 2. Now the next 2 have a 3 in common. Negative 3r plus 6 has a 3 in common, but the r is negative here and the r is positive in the parentheses. So I'm going to take out a negative 3, which will make this negative 3r, when you divide by negative 3, become positive, and 6 divided by 3 now becomes negative. And so that makes the 2 terms inside the parentheses the same, r minus 2, and I take my 2 outside terms. So 4rs minus 3, they form the second parenthesis there. So on all of these, the term inside the parentheses must be the same. The 2 on the outside must form the second set of parentheses there. So we have 3x to the 4th minus 21x cubed plus 4x squared minus 28x. Now, we should always ask ourselves, is there a GCF in this problem? And here we do have one. All of these terms have an x. So I factor one x out first for all of these. So just take away, right, the same problem, just take away one x. And now I'm going to divide it up into my first 2 and my last 2 terms of the 4-term polynomial. Now the x is a part of the answer. It's just not, we're not going to use it anymore. Okay? So here for 3x cubed and negative 21x squared, we have 3x squared, which leaves us with x minus 7. The GCF here of 4x and 28 is 4, which leaves us with x minus 7. So now our terms inside are the same. I bring down my GCF x. I have x minus 7. Those are the same. Then I take my 2 other terms, and they come together and form 3x squared plus 4. All right, so when we are doing grouping, everything, the inside term, when we factor the GCF of the first 2 versus the last 2, the term inside the parentheses must be the same. And as well, do not forget there's a possibility that once we turn this 4-term polynomial into binomials, there is a possibility that it can factor again, just like we have some trinomials that can factor again when it becomes two binomials. So this is the last part of factoring. We did binomials yesterday, grouping today. So today's worksheet's on grouping, and then tomorrow we'll have everything on one worksheet.